Hello everyone, welcome to another episode of Automation Digest. Today we'll be doing another DSA problem of converting integer into Roman numbers. So let's get into the problem, understand it, and let's code. So the problem is integer to Roman. It's a medium level of problem. We are given 7 symbols for the integer value. 1 is represented by I, 5 by V, and so on till 1000 represented by M. We are given some example as in 12 is written as XII. Similarly, the number 1994 would be represented by M, which is 1000, CM, which is 900. Adding them up gives me 1900, XC, which is 90, and IV, which is again 4. In total, it gives me the value 1994. Now to get into this problem, first we have to understand the conversion of integer to Roman. So let's start with the already provided 7 symbols in the question, where 1 is represented by I, 5 is represented by V, 10 is represented by X, 50 by L, 100 by C, 500 by D, and 1000 by M. Now in Roman, the second number or 2 is represented by 2 I's. Similarly, 3 is represented by 3 I's. But 4 is not represented by 4 I's. Rather, 4 becomes IV, which is 5 minus 1. I comes before 5. If I add I after 5, it becomes 6. Similarly, for 9, we will have IX. For 40, we will have XL, which is 10 minus 50. 90 will be again on the same lines XC, 10 minus 100. The number in between 90 to 100 will always be XC plus the value in addition to 90, which means 92 would be XC and 2 I's. Similarly, 95 will be XC and V. Now, on the same lines, if we want to reach 400, it is CD, which is 500 minus 100. That's why C is before D. On the same lines, 900 will be CM. Let's take another example. Let's say our number is 2149. Whenever we want to get the Roman numbers, first we have to understand how can that summation of number be formed. While doing that, let's start from the biggest number available in our list. 1000 is the biggest number that we can see. So if I divide it by 1000 twice, it gives me 2000, and the delta would be 149, which is no more divisible by 1000. The next number, which is 149, can now be divided by 100 once, and that leaves us with only 49, which can again be divided by 10 4 times, leaving us 9. We don't want to divide 9 any further. So just to summarize whatever we learned here, 2149 can also be represented by 2000 plus 100 plus 40 plus 9. 2000 is 2 times 1000, which means we can write
2M.
100 can be represented by C. 40 can again be represented by XL. 9 can be represented by IX. If we add this up, the value becomes MMCXLIX. And this is the solution that we need to arrive at. We were going with the maximum symbol of M because the constraint says the number will be in between 1 to 3999. Anything beyond this is not part of our problem. So let's go ahead and start the coding. As we were discussing, we need to store the 13 symbols for our usage. So let's go ahead and do that. These are two arrays. The first one represents the number and the second one are the symbols respectively. Now let's take a string builder to form the final string for our Roman numeral. Now if you remember, what we were doing is dividing the number by 1000, 100, 10. We were finding out the number of thousands which are present. Now, which means we have to have a loop to iterate through the values and understand if the number is divisible by the biggest number. If not, we move to the next and so on. Now, what we do is we find out the number if they are divisible by either of the values that we wrote here. That way, we can find out how many of this symbol can be used. So for example, 1994 requires 1000, 1900, 190 and 14. 1000 has M. So that gets replaced by M. 900 has CM. Again, we require to write CM. 90 has XC and 4 has IV. Now the number in our consideration needs to be subtracted continuously by the value if the value is positive or when the number is greater than value, and the value has to be iterated from the highest number to the lowest. While we are subtracting, we can continuously add the symbols which comes our way, and that would finally give us the result. So let's try to write that code. While the number is greater than equal to the value in the array, we continue subtracting it by the same value. And because we are subtracting, we have to append our string builder as well. The index remains the same, only the array changes. That's the reason we have the exact mapping of value and number. Once we are done with this, what we can do is we can just send the string result of it, which means we have to convert the string builder into string. Now the problem gets executed in 3 milliseconds, which beats 97.35% of the user. That's it for today. Hope you like the problem and the solution. I'll come up with another DSA problem. Till then, happy coding.